recording this, so I better. So consecutive integers. So let's just focus on that. If I start off with any integer, any arbitrary integer, so just pick one out of a hat, it doesn't matter, I'll put it right here at -2. All right, that's an integer. All right, any number that I plotted here would necessarily be an integer because that's how we defined it. If I want to get to the next consecutive integer, I would need to displace by one positive unit. So this is 1 unit of displacement to the right. All right. So 1 unit of displacement to the right. That's what it means to be consecutive. There's only 1 unit of displacement, 1 unit of movement, if you want. All right. We only need 2 consecutive values. So this would be an example of 2 consecutive values. But I chose to start at -2. What if I started at -15 or 172? You know, what we need to do is allow for one of the integers to be variable. So what we do is we let x be equal to some integer. All right, you could say an integer, you could say the integer, the first consecutive integer. I just say integer. X is an integer. All right. X plus 1, because that's our movement. All right, 1 unit of displacement. X plus 1 would be the next consecutive integer. All right, you could say the second consecutive integer. You could say the last, I mean, there's only 2 of them in this case, the last consecutive integer. But, I mean, as long as you get the idea that this is a different consecutive integer than the one that you already stated, then you're fine. All right? So we have our let statements accounted for. Now we have to actually write an equation to solve. Now, I didn't show this, but the directions for this entire set of problems said to solve algebraically. So yeah, I have Desmos up, which is great, but we would only use that to check our work. All right? We wouldn't use it to solve. We'd have to show the work here. All right? The sum. Sum is another way of saying addition. Of 2 consecutive integers is another way of saying equals. All right, so I have my 2 consecutive integers, x and x plus 1. What they're saying is the sum of those 2, so if I add those 2 together, the result is 13. This is the hard part of the problem. Everything after this should be properties of equality, combining like terms. I mean, that's not to say you're always going to get it right. I mean, I make a sign mistake here and there every now and again. I mean, sometimes for whatever reason, 2 plus 3 equals 7. I don't know. I just write the wrong thing sometimes. It happens. All right, but procedurally it should be okay. All right, it's getting to this step. If you're going to struggle with this kind of problem, anything involving word problems is almost always going to be in developing the equation that you need to solve in order to get an answer. All right, so if you're going to spend any time studying anything, it should be that. All right, so we got some like terms. I got an x, I got another x, meaning I have 2 x's. I got a positive 1, so tack that on at the end. Poor quality plus sign, so let me fix that. Is equal to 13. All I've done is combine like terms. Now, we don't have to always write what properties of equality we're using. We just got to be prepared to. All right? So we always just got to be ready for it. So it helps to talk it out. So what am I doing? I'm going to use the subtraction property of equality, or subtraction po. So 2x would be equal to 12. And then I would use the division property of equality, or division po. And I would get the result x equals 6. All right. It's an integer, so that's good. It would be lovely if it were the correct integer. So we'll do a quick double check in a second. But we do want to state what our final answer is. All right. If the sum of two consecutive integers is 13, find the smaller integer. Well, x plus 1, whenever you add something to a number, you're automatically making that number bigger, right? So the second consecutive integer would have to be a 7. So this is a 6, this is a 7. So that x actually happens to be the answer. So we would say, just make a brief statement, 6 is the smaller integer. Now I do want to check it and make sure that I didn't just botch up any of the algebra, but as far as stating a final answer is concerned, that's a pretty good way to state it. Right? The smaller integer is 6. The smaller of the two integers is 6. Right? Considering the two integers that are possible to be solutions to this problem, being 6 and 7, the smaller one is 6. I would never write anything like that. Right? Just keep it simple. So anyway, if we want to use Desmos to solve, remember y equals the left side of the equation. So x plus 1. Y equals the right side of the equation. 13. Desmos is not going to write the equation for you. It's not going to interpret a word problem and make an equation. You have to still do that. But once you have an equation, tap on any intersection, a gray dot will appear. Tap on the gray dot, and a solution will appear. It's the x value that we're interested in here because that's what we're solving for. We're solving for the value of x. All right. So it'll tell us that the result of the equation is 6. So if the question didn't tell us to solve it algebraically, you set up the equation and then just go right to x equals 6. All right. The point of a lot of these questions, just like I said yesterday, or implied yesterday, is the setup, not so much the solution. All right. So it's great that you got the answer. I want to see that you can write the equation. All right. Because what'll happen is a lot of people will gloss over the part where they write the equation and then show some algebra and then wonder why they only got 2 points out of 10 available. I'm like, well, you didn't do the thing that was the focus of the question, so you got to make sure you do that. All right? Find 3 consecutive even integers whose sum is negative 60. All right, so back to the drawing board here. So I'm going to pick an even integer. Let's say let's go with negative 4. Consecutive even would mean the next even number in the number line. So I'm going to hop over that negative 3 right on to a negative 2. All right, so I have 2 consecutive even integers, negative 4 and negative 2. I would have to do it again to get a third consecutive even integer. So hop on over again, and I get to a 0. All right. You see here that we're no longer dealing with 1 unit of displacement. All right, we had to hop over an odd number to get to the next even number. So that's 2 units of displacement. All right, so 2 units of displacement. So when I create my let statements, I would say let x equal an integer. I'll write n this time. The next consecutive even integer would have to be 2 more than this one. So x plus 2 would be the next consecutive even integer.
Does it matter, like if you're doing this like all your life, does it matter if you do 1 unit of displacement or 2 units?
Yeah, in this case, because it's even integers.
Oh.
Yeah, if it just said consecutive integers, then you would go with 1 unit of displacement. But because it's even, you have to go with 2.
How do you know which number to start on?
Oh, that number line was just an example. It was just like pick a number out of the air. The number that we're really starting on is some unknown value. Yeah. So x plus 4 would be the last consecutive even integer because we're starting off at some number x, unknown completely. We're adding 2 to it to get to the second value. We add 2 more to get to the third value. If you add 2 twice, you're really adding 4. All right. So again, just looking at the number line in variable terms, we're saying that we're starting off at, we still have negative infinity, we still have positive infinity. We're starting off at some value x. We're hopping over one value to get to the second value, so that would be x plus 2. We're hopping over another one to get to the third value, that would be x plus 4. All right. So this was just an example saying, okay, well, what if x was negative 4? Then the second one would be a negative 2. Then the third one would be a 0. But if x was, I was going to say 5, but that wouldn't make sense. If x was 6, the second value would be 8, followed by 10. Always adding 2, then 2, then 2, and so on. All right. So the last consecutive even integer. I'm going to resize because of my obnoxiously large handwriting, but then zoom in to make my too small handwriting obnoxiously large so you can see it. All right. Find 3 consecutive even integers whose sum is negative 60. All right. So back to a sum. So it's saying that I'm going to add these things together. So I have x, I have an x plus 2, and an x plus 4. The sum, so if I add them together, sum, is negative 60. Combine our like terms. I have 3 of those x's, so 3x. 2 plus 4 is 6. Whole thing is equal to negative 60. Then we get into our properties of equality. So I'm going to knock off the 6, so subtract. Subtraction property of equality. 3x would be equal to negative 66. Execute order 66. Division property of equality. Divide by 3. X is equal to a negative 22. When you solve for x, it better be an even integer. That was the whole point of the problem. Find 3 consecutive even integers whose sum is negative 60. I'm not worried about the negative 60 right now, but x better be an even integer. The fact that it's negative, okay, that's fine. You could have integers are negative and positive and or positive, so that's fine. So, and or, no, just or. So, this isn't my final answer though, because it said find 3 consecutive even integers. So I need all 3 of them. I have 1 of them. So for my answer, I would have negative 22. Now, I'm not going to require you to write anything like the 3 consecutive even integers are this, that, and the other thing. But you should list them. All right. So negative 22 plus 2, because the second one is x plus 2. We just figured out x is negative 22. So add 2 to that, negative 20. Add another 2, negative 18. Always a good idea to do a quick check. This one's pretty easy to check. I mean, even without using Desmos, the sum of these values should be equal to negative 60. So when you add these numbers together, you should get negative 60. If you don't, then you done did it wrong. Nah, it's probably just a minor mistake, but it might be, unfortunately, a minor mistake in the setup, which has a cascading effect through the whole problem. Because, you know, if you make a small mistake in the setup, then you have to do all the algebra over. If you make a small mistake in the algebra, then it's a matter of just doing a little bit, you know, from wherever you made the mistake, from that part on, maybe it's just a little bit of work. All right, so check your solution based off of the context, check it in Desmos, and see where you're at. All right. So the last one involves consecutive odd integers, the last one we're going to do together. This one's a little bit juicier. I'm going to get another number line in here. Find 3 consecutive odd integers. It's got some oomph. All right, it's got that je ne sais quoi. 3 consecutive odd integers such that the sum of the first and twice the second is 6 more than the third. All right. That's very wordy, but if we just focus on little bits at a time, how about 3 consecutive odd integers? We'll just start with, you know, baby steps here. Let's start with the simple stuff. What I would do is, just like I did with the case of consecutive evens, pick some odd number and ask yourself, how do I get from that odd number to the next odd number? Well, I'd have to hop over the negative 2 in order to get to the next one, which would bring me to a negative 1. All right, so again, this is just an arbitrary starting point. I could have started anywhere as long as it was an odd number. All right, that's a 2-unit displacement. All right, I would do the same thing if I want to get to the next consecutive odd integer. Add another 2. If this sounds familiar, it should, because it's the exact same approach that we did when we talked about consecutive even integers. It's still 2 units of displacement, and so it's still going to be the same general setup. All right, 3 consecutive odd integers. In fact, I can take all of this and duplicate it right down here, just changing every instance where I said even to odd. Oops, that's a D. I want it to be an O. All right. So the first value is some kind of integer. Now, in theory, it should be an odd integer, but you don't know how it's going to play out until it plays out. But we should actually say an odd integer. Just like in this last one, we should say an even integer. Just be a little bit more specific. The biggest question that I always get is, wait, it says odd integers in the problem, but you just put even numbers here. That has nothing to do with it. The 2 and the 4 has to do with displacement. It has to do with movement from one odd number to the next. So if I'm counting from, just count all the odd numbers that you can think of. 1, 3, 5, 7, 9, 11, 30, blah, 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 blah. Right? How do you get from one to the next? If I get from 21 to 23, I'm adding 2. 23 to 25, I'm adding 2. 25 to 27, I'm adding 2. All right? That it's always an addition of 2 to get from each consecutive even integer and each consecutive odd integer to the next one down the line. All right? So don't get thrown off by the fact that you see a 2 and a 4 here, and you think, oh, it says odd, why do I have even numbers there? That 2 has to do with the movement, not the number itself. All right. It's a very often a point of confusion. So if that was your first thought, don't feel bad about that. You're one among many. All right. So, was there a question floating out there? I thought I saw something. So find 3 consecutive integers such that, and by the way, this is the first battle. Once you get over this battle, this little hurdle, then things start getting easier. Such that the sum and I can't even speak. Such that the sum of the first and twice the second. Again, chunk it. Don't do it all in one shot. Use the is. I know that doesn't sound grammatically correct, but use the is as a boundary. All right? I use highlighters a lot, as you probably recognized. I'm going to go with a powder blue for those keeping score at home. So use that as kind of like a line of demarcation between one part of the equation and the other. All right? The sum of the first. Well, the first is x. Sum is addition. Twice the second. Well, the second expression that we wrote is x plus 2. So I want twice that. The whole expression, so I put it in parentheses. All right? So now I've taken care of this piece. Is means equals 6 more than the third. All right? 6 more than the third value. So this stuff is 6 more than the third value. So if I say that my age is 6 more than my brother's age, then there's a couple of things that you can do to find our ages. You could take my brother's age and add 6 to it, or you could take my age and subtract 6 from it. All right? So this is me. This is my brother. All right? If I tell you that this is my brother's age, x plus 4, and I'm just trying to conceptualize this for you. Instead of saying, sum of the first and twice the second is 6 more than the third, I'm saying my age is 6 more than my brother's age. I would take whatever my brother's age is, x plus 4, and add 6 to it. All right? If that doesn't help, then you start thinking about different ways in which you can conceptualize it. Like, for example, if I tell you, I use this one a lot. If I tell you, I pull you over, I'm a state trooper, you're driving over the speed limit. I pull you over, I come up to the car, and I say you were going 6 miles an hour over the speed limit. All right? There's 2 things that you can do. You can take your speed and subtract 6 from it to determine what the speed limit was. Or you could take the speed limit and add 6 to it to determine how fast you were going. Either way would work. All right? Once you have your equation, you solve it. We got a little distributive property here. By now, you probably recognize, for better or for worse, maybe you don't like it. Maybe you're realizing that the studying you did for properties is paying off a little bit. I tend to speak in terms of properties. So going back to the beginning of the unit, the types of numbers, real numbers, rational numbers, all that, the properties, all that stuff, it's going to come back over and over again. That's how I speak. And that's how math teachers from now on are going to speak. So you want to make sure you have that vocabulary down. All right. So I'm going to distribute. 2 times x is 2x. 2 times 2 is 4. On the right-hand side, I have some like terms that can be combined. X plus 10. All right. On the left side, I still have some like terms that can be combined. I have an x and a 2x. All right. 1x, assumed 1 coefficient. 1 plus 2 is 3. So 3x plus 4 is equal to x plus 10. All right, I'm going to rewrite 3x plus 4 is equal to x plus 10. Let's make sure this doesn't time out on me. Now I'm going to get my properties of equality involved. I want to get the x's grouped together, so I'm going to bring over the x by subtracting, subtraction property of equality. I'm going to bring over the 4 by subtracting, also subtraction property of equality. 3x minus x, remember it's the understood coefficient of 1. 3x minus 1x is 2x, is equal to 6. Now, the last step, I can actually use my division property of equality, or division po, if you will. And we get x equals 3. If we got anything other than an odd integer here, I would be nervous, right? I would know I made a mistake. I would be nervous that I made a mistake really early on and would have to do everything all over again. That would be a problem. I would not be too keen on that, all right? Find 3 consecutive odd integers. We know one of them is 3. The second one, add 2 to the 3, you get a 5. Add another 2, you get a 7. All right. So, you know, it's a lot, but you could see that it's very procedural. It's just, I wouldn't categorize this as a great deal of fun, but it is skill-based. So if you get this down, you're going to be in pretty good shape. But you could also see that the algebra for this one was a little bit more involved than some of the other problems. Well, definitely than the other 2 that we did. So if you were ever going to get Desmos involved, you know, if a question didn't ask you to do it algebraically, this would be probably along the lines of something that you would consider using Desmos for. All right. So, you know, if you haven't become more comfortable using Desmos, definitely take the time to do that, because there is a benefit. All right. Nope.